Hello everyone! So today we are going to look at Chapter 2, Pressure in Liquids. So before we move on, let's look at the learning outcomes for today's lesson. We are going to focus on 5 learning outcomes in order for you to understand the concept of pressure in liquids. The first learning outcome is to communicate about the concept of pressure in liquids. Later on, we will investigate factors that affecting pressure in liquids. To analyze these factors, we will have to go through 5 characteristics of pressure in a liquid. Next, we will communicate the applications of pressure in liquids. For examples, we will learn how the position of water tank affects the pressure in liquids and how the thicker wall at the bottom of a dam will help to withstand the large pressure of liquids. In 2.4, we will learn to describe the principle of pressure transmission in an enclosed fluid, which is very related to Pascal's principle. In Learning Outcome 2.5, we will communicate the applications of Pascal's principle in our daily life. This principle somehow is very useful as it can be used in hydraulic system. Today, we can see this hydraulic system have been used a lot in industries to facilitate their works. From all these learning outcomes, hope you all can understand and master the concept of pressure in liquids very well. Before we learn the concept of pressure in liquids, let's recall the concept of pressure. So, what is pressure? Pressure is defined as the perpendicular or normal force per unit area acting on a surface. The SI unit of pressure is Newton per square meter or Pascal. For better understanding, a woman wearing high heel shoes sinks deeper into soft ground than a female student wearing flat school shoes. Both the woman and the student have the same body weight acting downwards on the ground. The woman's weight is spread over a smaller area of her shoes, thus exerting a higher pressure on the ground. The student's weight is spread over a larger area of her shoes, thus exerting a lower pressure on the ground. High and low pressure have been used in different situations. Now, let's look at the applications of pressure in everyday life. The magnitude of pressure exerted on the surface can be increased or decreased by adjusting the magnitude of force applied. Force also can be adjusted by increasing or decreasing the surface area of contact. Applications of high pressure. A sharp knife can be used to cut an object easily. This is because a small force applied on a very small area of the knife edge can produce a large pressure for cutting the object. Now, we will look at the applications of low pressure. Tall buildings are usually built on a base of large surface area to decrease the pressure and to prevent the building from sinking into the ground. A wooden block kept on a table exerts a force on it, and we know that the wooden block is a solid substance. What about liquids? We know that liquids are kept in containers. Do liquids or fluids exert pressure? Yes, they do. What is pressure in liquids? Pressure in liquids is the pressure at any point in a liquid is due to the weight of liquid above the point. When a liquid such as water is poured into the Pascal vessel shown in the figure, the water in each tube rises to the same height. This shows that liquids always find their own level. At the same level or depth, the liquid pressure must be the same, otherwise liquid will flow to equalize any pressure differences. To understand the factors affecting pressure in liquids, first, we must know the characteristics of pressure in a liquid. First, pressure in a liquid acts equally in all directions. It depends on depth, density of liquid, and affected by force of gravity. However, pressure in a liquid does not depend on surface area. Now, let's look into these 5 characteristics of pressure in a liquid. The pressure at a point in liquid acts equally in all directions at a particular depth when the tin is drilled with several identical holes at the same height. Water will spurt out to reach equal distances from the circumference of the base at equal speeds. This shows that the pressure at any point in a liquid acts equally in all directions. Depends on depth. Holes are made at different heights on the side of a tall vessel. These holes are fitted with side tubes which are plugged up and the vessel fills with water. On removing the plugs, it found that water spurts out fastest and furthest from the lowest tube. This shows that liquid pressure increases with the depth. Depends on density of liquid. A hole is made at the same height on the side of each two similar tins filled with water while the other one is filled with cooking oil. It is found that the jet of oil falls nearer to the tin and flows slower than the jet of water, although both tins contain equal amount of oil and water. This shows that oil pressure is less than water pressure, therefore the pressure of a liquid increases with density. The pressure in the liquid is affected by the force of gravity. A liquid with a larger force if gravity will exhibit a larger pressure if the other factors remain the same. This is because higher force of gravity exerts higher pulling force on liquid, hence causing the liquid to become heavier. For example, the pressure at a particular depth and liquid on surface of the moon is 1/6 of the pressure of the same liquid on the surface of the earth. Does not depend on surface area. The pressure and the liquid is not affected by the surface area. Figure shows that tubes of different shapes and diameter have the same pressure at the same depth, since the water level is the same in each tube. So, from these factors that affecting the pressure in a liquid, we can derive the pressure in a liquid by relating pressure in a liquid to the depth and density of the liquid. Consider a cylindrical container of height h and cross-sectional area A which is filled with the liquid of density. The first step is to find the volume of liquid in the container by multiplying the cross-sectional area to the depth of liquid in the container. Next, using the volume of the liquid and liquid density, find the mass of liquid in the container. At this point, we can find the force acting on point X. Pressure on point X is calculated by using formula force over area. The expression P is equal to H times rho times G shows that the pressure at any point in a liquid at rest is directly proportional to the depth of the liquid density, and the gravitational strength. Now, let's move on to applications of pressure in liquids. In a public water supply system, water will be pumped into water treatment plants from the river and dam. After treatment, water is pumped up to a water tower tank situated higher than all the houses in that area. A water tank usually built at the top of each house to store water and maintain constant water pressure. Due to the gravitational pull, water in the tower tank is maintained at a high pressure, and this enables water to flow to the houses of the consumers which are lower. The second application of pressure in liquids is the walls of a dam. A decameter is built across the river to collect water for the purpose of water supply, irrigation, and generation of hydroelectric power. A thicker wall is required to withstand greater pressure since water pressure increases with depth. The third application is fire hose used by a firefighter. A firefighter requires a fire hose for directing a water jet at a very high pressure to put out fire in a high-risk building to produce a pressurized water jet. The water is accelerated by an electric pump before flowing through the fire hose. Pascal's principle. What is Pascal's principle? The transmission of pressure in the liquid can be explained with Pascal's principle. Pascal's principle states that pressure exerted on an enclosed fluid is transmitted equally to every part of liquid. In transmission of pressure in liquid, we can find pressure exerted in liquid. Due to the difficulty in compressing liquids, the pressure that exerted to a liquid would be transmitted to all parts of the liquid. The following figure shows the apparatus that is used to transmit pressure uniformly through water. When the piston is pushed inwards, water is compressed by the applied force. The force of compression per unit surface area gives rise to pressure exerted on the water. Since the volume of the liquid is fixed, the applied pressure is transferred evenly in all directions in the liquid. Then, water will squirt with equal force from all the holes on the glass bulb. The idea of pressure transfer in this liquid is clearly stated in Pascal's principle. Hydraulic system. The basis for all hydraulic systems is expressed by Pascal's principle, where this hydraulic system uses a fluid under pressure to drive machinery or move mechanical components. Pascal's principle can be used as a force multiplier in a simple hydraulic system. The figure shows how a simple hydraulic system works based on Pascal's principle. This system consists of two cylinders of cross-sectional area, which are A1 and A2 respectively. When a small force F1 is applied to the smaller piston X1, a large force F2 is produced on the larger piston X2 due to the pressure transmitted from piston X through the liquid. Based on Pascal's principle, pressure in liquid is transmitted from piston X to piston Y. Applications of Pascal's principle in everyday life. The hydraulic system used in Pascal's principle is very important as this system is widely used in hydraulic jets, hydraulic elevators, vehicle brake systems, and aircraft hydraulic systems. Hydraulic systems are used in moving mechanisms to obtain a large force by the application of a much smaller force. A hydraulic lift can be used for lifting heavy load such as a car. This hydraulic lift works based on Pascal's principle. A hydraulic lift consists of two cylinders of different diameters. Each of the cylinders is filled with a piston and oil. When a switch is pressed on, compressed air is pumped into the small cylinder to exert a force F1 and the pressure on the oil. This pressure is transmitted through the oil to the large cylinder. Thus, a force F2 which is strong enough to lift a heavy load such as a car is produced. Next example is hydraulic brakes. Hydraulic brakes are used as a braking force on all the wheels simultaneously at the instant the brake pedal is applied. There are two types of brakes used in a car. Disc brakes at the front wheels and drum brakes at the back wheels. When the brake pedal is pressed by the driver's foot, pressure is exerted on the brake fluid by the large piston in the master cylinder. This pressure is transmitted through the brake fluid to all the small cylinders of the wheels. At the front wheels, the small piston A exerts a force to push the brake shoes against two pieces of steel disc. Thus, the car is slowed down or stopped by the frictional force between the brake shoes and the steel disc. At the back wheels, the small piston B exerts a force to push the brake shoes apart against the brake drum. This causes the car to slow down or stop. When the brake pedal is released, the small pistons A and B return to their initial positions. A spring connecting the two brake shoes at the back wheels contract and pull them away from the brake drum. The wheel is then free to rotate again. Let's test your understanding. The wall of a dam is built thicker when approaching the bottom. What is the principle used in the construction of dam wall? A. Water pressure is directly proportional to the surface area of the dam. B. Water pressure is directly proportional to the depth of the water. C. The water pressure is inversely proportional to the surface area of the dam. D. Water pressure is inversely proportional to the depth of the water. That's all from me today, and thank you for watching.